Okay, so at this point, you have finished part one. Now we're going to do slightly more complicated questions. So at times, when solving radical equations, we need to use other tools like factoring, box method, etc. Okay, and you're going to see that in the problem that we're going to do next is you're actually going to have to use factoring and box method in it. Okay, one last note. In addition, we may have extraneous solutions. We're going to talk about what that is. So as you can see, extraneous has the word extra because what this basically means is these are solutions that are actually not true. Oops. When you plug it back in. Back into the equation. Okay, so in this example that I'm going to show you, we're going to actually get two different answers, but one of them is extraneous. Okay, so what I want you to do in your notes is I want you to draw a line, like a dotted line like this. Split your paper up like this because we're going to do some work on the left side and some work on the right side. Okay, and let's say the question that we have is square root of x plus 1 equals x minus 5. Okay, so if you notice, our radical is already isolated, right? There's nothing else on that side. So we can go ahead and square both sides, right? And as we know, when we square a square root, it cancels out the square root. So we are left with x plus 1 equals x minus 5 squared. Now, here's the thing. We gotta, what is x minus 5 squared? Well, we can actually expand that, right? And we're gonna expand it by doing the box method because x minus 5 squared is the same thing as x minus 5 times x minus 5, right? And now we multiply to get the stuff on the inside. So x times x is x squared. X times negative 5 is negative 5x. Negative 5x again. And then negative 5 times negative 5 is positive 25. If you notice, these are our like terms, right? So in your calculator, if you do negative 5x minus 5x, you're going to get negative 10x. And then we just bring down the x squared and the plus 25. So I can now rewrite this part as this. These are the same thing. So I'm going to have x plus 1 equals x squared minus 10x plus 25. Now, in this question, we can't just solve for x because we have x squared, we have x with the x plus 1, and we have x squared minus 10x, right? Whenever you see something with x squared, instead of solving for x, we have to move everything to one side because we're going to actually factor. So what we're going to do is we're going to move everything to the side that has x squared. So for example, I have this positive x, so I'm going to subtract x on both sides. For this plus 1, I'm going to minus 1 on both sides. And you'll see these cancel out. So what I'm left with is with x squared, right? This is technically a negative 1. So negative 10 minus 1 is minus 11x, and then plus 24. And this is just going to equal 0, right? Because everything canceled out. Now, in order to solve this equation, this is what we talked about in the last unit. You could use quadratic formula, but that's going to take you a long time. And if you notice, we can actually factor this. So we're going to find the factor pairs of 24. We have 1 and 24, 2 and 12, 3 and 8, 4 and 6. To get negative 11, right, if that's going to be 8 and 3. And both of them have to be negative because negative 3 minus 8 does give us negative 11. So we can rewrite this as x minus 3, x minus 8 equals 0. And now I can solve this by setting each parentheses equal to 0. Right? So I have plus 3, so I have x equals 3, and I have plus 8, x equals 8. Okay, so now, as you notice, I have two potential solutions. But what I have to do is I have to do a check. And for the check, we're going to plug these answers back into the original equation. So the original equation was square root of x plus 1 equals x minus 5. So let's first check x equals 3. So anytime I see an x, I'm going to plug in a 3. So I have square root of 3 plus 1 equals 3 minus 5. If you put this whole thing in your calculator with the square root, you're going to get 2, right? Because square root of 4 is 2. If you put this side in the calculator, you're going to get negative 2. If you notice, this is not a true statement. 2 does not equal negative 2, which means this x equals 3 is extraneous. It's not actually true. It's kind of a fake one. If we now check x equals 8, let's see if that one works, because sometimes they both may be extraneous. So I have square root of 8 plus 1 equals 8 minus 5. Again, you can put this whole side in your calculator with the square root. You're going to get 3, and then 8 minus 5 is also 3. This is a true statement. So your only solution is actually x minus 8. This is your only solution. So, as you can see in this equation, in order to solve this radical equation, we had to use box method as well as factoring, okay? I'm going to post another video that's like another example. If you feel good, you do not have to watch that video, okay? So this is an optional extra example, which is the next video. Otherwise, move on to the practice.